Welcome back, welcome back, welcome back. I'm Lisa Blackburn, and this is my YouTube channel for everything I want to talk about, science and math. And when we started doing this video, we had a fire alarm go off. So you can probably see, I thought it was posting the whole thing. I thought we had recorded it, and it didn't. So there's a video with like 1 minute with us starting and then the fire alarm going off. So I'm going to teach to the video camera because there's no students here now, and there's gonna also have to explain all this stuff. Part 2 of the video yesterday cut off because I was trying something new, and of course it didn't work the way I wanted it to. But anyway, so what this is the elements of chemistry, and what we're going to be talking about is bonding and periodicity. So that word periodicity has to do with the periodic table. And what we're going to do first is we're going to read a very scientific book. And you're going to really have to concentrate to extrapolate the science out of it. Ready? Da-da-da-dun. The People in My Family from Sesame Street. I know. You're going to have to really pay attention to get it. I'm going to read it to you. Then we're going to talk about the science, all right? So this is how it starts. Oh, I have 5 people in my family, and there's not a one of them I'd swap. See, they're going to the park. There's a sister and 2 brothers, and a mother and a pop. That's me. 5 is such a lovely number. I'm awfully glad I have 5 people in my family. 1, 2, 3, 4, 5. And look, there's some foreshadowing of the coming conflict. You know, every good story has to have conflict. Well, I've got 5 monsters in my family, and we all have lots of fun. A furry wife, a scary husband, fuzzy daughters, hairy son. 5 is such a scary number. Oh, I'm so glad that I have 5 monsters in my family. 1, 2, 3, 4, 5. Now here's the climax. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now the denouement. Remember that word from English class? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now they're all happy having a picnic. Now there's little questions if you're in preschool, but you're not. You're in chemistry. So what does this have to do with chemistry? And stop thinking nothing. Yes, it does. All right, so here I've got these 2 groups. And if you will remember on the periodic table, see, I told you I had to do with chemistry, that the lines going up and down, or the columns, are families. Now you see how it all fits? Families. So we're going to be talking about these families. That's what has to do with the word periodicity. So we got to extrapolate the science from this. Here we have 2 families, and they are they more? My question I would ask if you were here is: are the members of this family more like each other, or like their corresponding member of the other family? Are these guys more like each other, or are they more like their corresponding member over here? So like this dad, is he more like his Muppet family, or is he like the dad over here? I hope you said he's more like his family. That was the answer I wanted you to say. How are these Muppets alike? Well, they are not furry. They're more smooth. We said they're smooth posers, like Adventure Time. Lumpy Space Princess says that about Brad. He's a smooth poser. That's way before y'all's time. In the mid-90s, mid-2000s, around 2010, maybe 12. But anyway, maybe some of you watched reruns of seen Adventure Time. So here is they're smooth. These guys are furry, and that makes them more alike. They have googly eyes. They have black mouths. These are the things that this family has in common. Now, the dads, who are representative members of their families, do have some things in common. I asked the kids, what do they have in common? And they said back, and this is what you're missing because I don't have any kids to talk back to me, I'm having to talk back to myself, is that they're the largest member of their family. Just like on the periodic table, we will have ones like that. That they had more eyebrows than the rest of their families. In one class said that their hair on top was either gone or not much, with poofs on the side. I thought that was good observation from my class. So that is what we're looking at. Now let's bring it back to I know as fun as that was, let's talk about the periodic table. So the periodic table has families. Like this family is the noble gas. They don't react with anybody else, usually. These are the halogens. They all disinfect. Every single one of them kills germs. Over here we have the alkali metals and the alkali earth metals. These guys are all extremely reactive. They react with the oxygen in the air. They react with the water in our air. We have very humid air here in Georgia. And it would react with those. So if I buy these, but I found out from Miss Weeks I'm not allowed to. I was allowed to in Cobb County. But if I buy these in this first column, they come, which I won't since I follow the rules, but they come packed under oil. I found a video I can show y'all instead about it since I can't do it. I used to always do the experiment that's in the video for my kids. It was very exciting. But we'll just watch a video. We'll obey the rules and watch the video. So anyway, they come packed under oil. They're all extremely reactive. So these families are alike. The reason why they're alike has to do with our last unit. We talked about the electron configurations. Remember, 1s2, 2s2, and then comes 2p6. Electron configurations, yes, they're really slick. There's more to that song, but we'll stop there. Anyway, when y'all learned that last time, that causes, because the families have the same configuration in their valence electrons, it causes them to have the same properties. So they are like their families. Now, also though, the representative members do have some things in common. If you look across these families, like if you look at a lot of them, their smallest member is so small, it's a gas at room temperature. Hydrogen, nitrogen, oxygen, fluorine, helium, all gases. So many of these families are very similar. If you look at the heaviest ones of each family, the biggest ones, every single one of them are radioactive. So the representative members, they're the biggest. They're the biggest ones. And the ones up top are the smallest. So just like in our families here, they do have some similarities with their representative member, but they have more similarities with their family. The other class pointed out something I didn't notice. The smallest one of each of these families are pink. So they said that's like being gases at room temperature. Okay, so that's our first thing. So on our notes, it is people in my family. Where did I put my little pen to write on the board? Here it is. Okay. So we're going to fill it out in case you're at home, you're sick, and you have to have it filled out. I wonder what color will show up best for you. Let's try red or hot pink. How's that? We'll see what shows up. So our book was People in My Family. And we're going to use this analogy to understand the periodic table. Okay? Now, the columns are more like each other than the periods. The rows are the periods that would have the representative members, so that have similar members. So there's the mom, okay? And we talked about that the moms are alike, that they both had orange hair, but they seem to have different texture of hair. That's what we talked about in the last one. Okay, now, the thing that's going to make so much in chemistry make sense is if you will understand what elements want. And what elements want is to, I'm putting on a crown, to be like the noble gases. Remember the noble gases? They're over here: helium, neon, argon, krypton, xenon, radon, that first column. All right, so they want to be, just like the people in England want to be like William and Kate and the royal children, the elements on the periodic table want to feel like a noble gas. I have to write real slow on this. If I don't, it just freaks out and won't write. But Miss Raymond can write on hers fast, and I don't know why. I don't know why she can do it fast, I can't. My board makes me write slow. That's all right. Sometimes you gotta go slow. Now, can they be noble gases? No, they can't. They cannot be noble gases, can they? Because they are always gonna be what they are because of the number of protons. The number of protons is what makes the element what it is. Got that? So they're going to feel like a noble gas because they're going to have the same electrons in the same configuration as a noble gas, and that's good as the noble gas before them, usually. But we'll talk about that more. But that's going to make them feel like a noble gas because they're going to have full valence electrons, and we'll talk more about that too. Okay, so that's what it is. What they all want, it's called the Octet Rule. The Octet Rule, they all want 8 valence electrons. And this causes trends in the periodic table. So you can draw a little arrow to the crown. And let me explain this to you. Now, first of all, for the other group, I said that's why we have the octet is why we have the octopus. And I sang them the octopus song. It goes like this. And you know I'm a bad singer, so just, I know that too. How many legs do an octopus got? 8 legs, 8 legs. 9 legs? No, 8 legs. 6 legs? No, 8 legs. How many legs do an octopus got? 8 legs. It's by Flippy the Fish Head. I did not make this song up. I guess it's teaching the number 8, like how Sesame Street does. But you can tell it's not teaching English because how many legs do an octopus got? It should be how many legs does an octopus have? But I guess it's better lyrically. My husband's a musician, and he says this. There'll be like bad grammar in a song, and I always want it to be corrected. And he says, no, it's better lyrically. So there you go. All right, so I just had to sing Flippy the Fish Head for you. Okay, so these periodic trends, they all want 8. Now I want to tell you a little story about 8. So the guy who figured this out, the scientist, he started noticing that the elements on the periodic table wanted to have 8 electrons in their valence shell. And he knew that there are patterns in nature. There are patterns in nature. For example, the same mathematical formula, which is very complex, is used for a snail's shell and for a spiral galaxy. Same mathematical spiral formula. It's very complex. They both use this same formula in their design. Now, does a snail have anything to do with the spiral galaxy? Not much, unless the snail is in the spiral galaxy, like a snail here in the Milky Way galaxy. But mathematically, this pattern is repeated. And this is not just snails and galaxies, it's throughout nature. You see these same patterns repeated over and over again throughout the whole universe. So this guy, chemist, said that he had noticed that it seems like that the elements want 8 valence electrons, just like how there are 8 notes in a musical scale. And all the other scientists said, you're stupid. There is nothing in common between music and atoms. He died without finding out he was right. So they eventually went, oh, he's right, there is. And music is not just random noises. Music is actually based on physics. So next year when you take physics, you're going to learn about the physics of sound, and you're going to learn about octaves and what these sound patterns have in common. And it has to do with waves. And remember, the electrons can act like a particle or a wave. So there are these repetitions throughout the universe. And they might even be found in weird places like music, things that seem to have nothing to do with each other. But they're there. So as a scientist, keep your eyes out for them. You might find them. And this is another point that I was saying to my class yesterday, is At one time, the established scientific community believed that the sun went around the earth. And Galileo had the guts to say no. So, I know you're all going to be scientists. You have to be, because I just want you to. So when you grow up and you're a scientist, don't be afraid to question the established scientific community. Everybody can be wrong. You might be the one person who's on to something that no one else has thought of. Follow it. Follow your instincts. Don't just make up junk. Have scientific reasons for it, but, follow it. Follow the evidence. Follow the evidence where it leads. Don't let the established scientific consensus bully you into checking your brain at the door. Be like Galileo. Be a rebel. Be a science rebel. All right, there you go. That's my little. And the other thing is I always try to stress to kids that they get the idea that everything's already been discovered and that we know everything and science is established and it's done. Shut the book. Absolutely not. There is tons of things we believe today that later are going to be proven wrong, and there are tons of things that we haven't even thought of yet that are going to be discovered tomorrow. So there is a place for you in science. It's not finished. Okay, off my soapbox, back to the notes. All right, so what we're going to talk about next is periodic trends, and how we're going to understand it and remember it is we are going to think of it as that these electrons are like children. The electrons are going to be thought of as children. And there's our little child, and this is David. We're going to talk more about David in a minute. This is my sister's son, David. And we'll be talking more about him in just a minute. But my sister had 6 kids. I only had 3. And we're going to talk about the difference in big family dynamic and small family dynamic too, applying it all back to the periodic table. All right, so first of all, looking at the periodic table, let's look at sodium right here. Sodium wants to be like neon. What would sodium have to do to be like neon? It would have to lose 1 electron. So that's what every element in this very first column, the alkali metals, wants to do. It wants to lose 1 electron. In the second column, how many do they want to lose? That's right, they want to lose 2. And if they do, then they will feel like a noble gas. Remember, electrons are negative. So if this family, if one of them loses 1, what is its charge going to be? +1. So I want you to take out your periodic table, and I want you to write at the top of the column, first column, +1. That's a 1. Mine's hard to read there. I wrote on my hand. And then on the second column, how many are they going to lose? 2. So what will their charge be? +2. Now we're going to skip these for now. And if we look at this third column, how many do they want to lose? They want to lose 3. +3. Now, so what I say is these are the bad parents that leave their kid on the shelf at Walmart, drop them off at the police station, leave them at a bus station. These are, in real life, that's terrible, but we're just talking about atoms. But these are the ones who want to get rid of their children. So alkali metals and alkali earth metals want to lose their little children electrons. Now, non-metals, the ones near the noble gases, like the halogens, remember the noble gases don't want to do anything. So we'll put a 0 on top of their column. The ones next to them are the halogens, and what would they want to do to feel like a noble gas? What would chlorine want to do to feel like argon? They'd want to gain 1 electron, wouldn't it? And if it gained 1 electron, what would its charge be? It would be -1 because electrons are negative and it's got 1 more, so it's -1. So we're going to put -1 on the top.